Hello friends, today we'll be discussing trigonometry. Trigonometry, if we talk about trigonometry, it is used in varied fields like astronomy. You will use it in study of oceanography and astrophysics. So if you are interested in trigonometry and you continue studying science based in mathematics, then trigonometry will never follow your footsteps. So it will always be your company, and it is one of the most interesting topic. So to understand this, we need to know the basics of trigonometry well. Otherwise, in the higher level, you will always find it difficult. So to understand the basic of it, let's start today. So first of all, I want to talk about the right angle triangle. In a right angle triangle, what do you mean by right angle triangle? If one of the angle is 90 degree, it is called a right angle triangle. Now I want to talk about the angle considered. According to the angle considered, if I show you these two triangles are same, but the angle considered are different. So what happens when the angle considered are different? When angle considered is taken as B, then the side opposite to the angle considered will be the perpendicular. So that means in this figure, AC is the perpendicular, and the side attached with the angle considered is called the base, and the side opposite to 90 degree, which is the longest, is called the hypotenuse. So likewise, you will see that angle considered is now changed from B to A. Now angle A is the angle considered. So the side opposite to angle considered is called the perpendicular, and the side attached with the angle considered is called the base. Again, the longest side or the side opposite to 90 degree is called the hypotenuse. You will see that hypotenuse does not change, but perpendicular and base interchange when angle considered is changed. Now, I want to talk about Pythagoras Theorem. This will be used quite often in the chapter trigonometry, that you need to really understand this. So, Pythagoras Theorem is used only in right angle triangle. So if you have a right angle triangle, then Pythagoras theorem says that it is equal to square of the hypotenuse equal to sum of the square of the other two sides, that is perpendicular and base. So this is the sign representation of Pythagoras. In terms of side, if I convert, you will see in this figure AB is hypotenuse, so AB square, and AC is the perpendicular, so perpendicular square plus base square. This is our Pythagoras theorem, and we will be using this quite often in the chapter trigonometry. Now we'll talk about trigonometric ratios. To remember this, these trigonometric ratios are new to you guys, especially when we do boards, like when we give our board exam. If you're not sure about trigonometric ratios, then the whole chapter of trigonometry becomes very confusing. So to remember this trigonometric ratios easily, there are some very common, very popular shortcuts which I'll be teaching you now. That is, if some people have curly brown hair, turn permanent black. So now what do I do is I underline all the initials and so sum will be equal to divided by this, equal to divided by this, and equal to divided by this. So this initial of this phrase will have conversion into trigonometric ratios that we'll be doing now. So from here I implies that this S stands for sine theta. The full form is sine theta. In short, you write SIN sine theta. So this is sine theta is equal to P by H. P by H means perpendicular by hypotenuse. If you look at this figure, our perpendicular is AC and our hypotenuse is AB. So likewise, what does this C stands for? C stands for cosine theta. In short, you write as cos theta. This will be equal to base by hypotenuse. so B by H. Now if you look at the figure, our base is BC and hypotenuse is AB. Now the last part is turn permanent black. The initial is T, P and B. So this implies to tangent theta. This will, in short, you write it as tan theta. So this will be equal to perpendicular by base. So if you look at the figure, this is equal to perpendicular is AC and base is BC. So this is our trigonometric ratios. And please remember, trigonometric ratios are never expressed in capital letters. You should always write it in small letters. So this is our trigonometric ratios. Further continuing, if I show you this, say you know the basic idea that if I have A divided by B, if I have a fraction A divided by B or a rational number A divided by B, if I divide both the numerator and the denominator by C, it does not affect the rational number or the fraction, because if I simplify this further, so you will see that this is equal to A by C and the denominator comes up and turns into C by B. So this and this cancel, and finally I have A by B again. So using this idea, if a fraction or a rational number is given and if we divide both the numerator and denominator with the same constant, with the same number, then it does not affect the value of the fraction. Using this idea, I continue this with if I say AC is perpendicular, if you look at the figure, AC is the perpendicular and BC is the base. So if I divide both the numerator and denominator by hypotenuse, so AC is perpendicular, I divide AC by hypotenuse AB, and BC is divided by again AB. So as I said, if the numerator and denominator is divided by the same quantity, it does not affect the value, overall value, it remains the same. So in this case also, I'm dividing both numerator and denominator by the hypotenuse, so it does not affect the tan theta value. So AC by AB, that is perpendicular by hypotenuse is equal to sin theta. So the numerator becomes sin theta, and BC by AB means base by hypotenuse means cos theta. So sin theta by cos theta. Since this is the another representation of tan theta. So what are the trigonometrics that you have learned so far? Sin theta is equal to perpendicular by hypotenuse, that is AC by AB, considering the figure. Cos theta is equal to base by hypotenuse, and tan theta is equal to perpendicular by base or sin theta by cos theta.